Assalamu alaikum and a wonderful day to everyone. Welcome to Integrated Design Project KIX 3001. As for today, we're gonna look at the last topic on site preparation. This consists of two subtopics, which is on the definition and site preparation process. Site preparation involves the demolition or wrecking of buildings and other structures, clearing of building sites, and sale of materials from demolished structure. Site preparation also entails blasting, test drilling, landfill, leveling, earth moving, excavating, land drainage, and other land preparation. Also included are tunneling, overburden removal, and other development and preparation of mineral properties and sites, except oil and gas sites. So if at site you have all of these items on top, you clearly need to take away everything so it's clean to start construction. In site development, the site preparation process is the first task that must be completed. Engineers need a clear and properly prepared site to start a new project. In a site that is unfriendly to the project can destroy plans, hinder building permits, and damage the overall project. Basically, we just want to do it one time. It is a challenging activity that must be dealt with before any building project can begin in earnest. With civil engineering projects, the site preparation can be demolition, regardless above or below, soil clearing, soil testing, site plan designs, zoning restriction, environmental concern, and coordinating how everything on the project should run. Preparing your site properly to begin with means a much safer, more productive working environment and a total project that is up to standard and in code. There are 5 steps of site preparation. The first is site clearing. This is the first task of site preparation. The site should be in cleared and graded condition. It involves the removal of trees, demolishing buildings, removing any and all underground infrastructure, and any other obstacle that might affect the construction process in the future or hinder the project to be done. The second step is the site surveying. If your building block is not clearly identified by survey pegs, you cannot be certain that you're building on the correct block. A surveyor will survey the site and line out exactly where the structure or road project is to be built. The surveyor process is not an option, it is a requirement for most zoning and permitting processes. Surveying is the translation of a contractor's set of construction plans into a physical representation on the project site. The function of the surveyor is to locate the boundaries of the structure to be built and is denoted with physical markers, usually of survey stake in a horizontal position. However, the survey's marks are also communication to the contractors as to the actual elevation and the required cut-off field necessary to obtain design elevation. It is also includes the checking of improvement and temporary construction item placed to construct those improvements. Contractors use the surveyor's mark to verify the horizontal and vertical location to the construction plans. The third step is on soil testing. Soil testing is an important test that needs to be done before the site is purchased. The composition of the soil must be known so as to examine the ability to withstand structure and to test the ability to absorb water. The site engineer will insist that you do all necessary soil testing before commencing any structural tasks on the soil. If the soil at the site is not suitable for future project, then there may be no choice but to look for another site which has soil suitable for the project. The fourth step is on site plan design. After the soil testing is done, all necessary drainage and septic tanks are installed. The next step is to modify the design to indicate placement of septic systems and all necessary fixtures. Nothing can be done without designing the site and above all marking permanent records of what is underground. A construction site is a living, breathing thing. It changes daily as placement of a water tank underground changes slightly because of underground rock formation, for instance. This must be noted for future references. The site plan will show newly developed access road for construction vehicles and temporary storage areas for supplies to be delivered. The site plan will also depict where the building should be after it is built. Unlike other steps taken in site preparation, the site plan is updated in the field and revisions are carried out in the office by consultants. The last step of site preparation is site investigation. Geotechnical site investigation performed in order to characterize soil, rock, and groundwater condition of the proposed site. A geotechnical site investigation is the process of collecting information and evaluating the condition of the site for the purpose of designing and constructing the foundation for a structure. The steps taken to geotechnical investigation are listed in the next slide. A good planning and management of a geotechnical site investigation is a key in obtaining sufficient and correct site information. This information is then used for designing structure in a timely manner and without extra costs and surprises for the estimate of effort needed. The collection of geotechnical data and preparation of a report for a proposed structure should be considered in following stages. First stage, the project definition prepared by the owner in conjunction with an architect. The project definition consists of architectural engineering foundation criteria such as loading and settlement. There should be a report for in-ground infrastructure, on-ground foundation, parkings, road and curb structures, and above-ground structures. This report may also offer components such as service life of structure and proposed design and construction schedule. Preliminary site and project evaluation should be conducted by the geotechnical consultant selected for the site investigation. It consists of preliminary site review of past geotechnical investigations, including that of nearby sites, a selection of likely foundation design based on published literature, and the geotechnical consultant knowledge of the site. The preliminary evaluation and consensus by the owners are used to develop the detail of the proposed geotechnical site investigation. The geotechnical site investigation will also determine if the building phase will be done in 1 or 2 steps. So this is the third stage. In the case of small buildings located on good ground condition, this phase could be done by means of an office evaluation to be followed by the geotechnical SI. In the case of major buildings and possible difficult groundwater or underground springs or sinkholes, this phase could be done in 2 steps. The first one, it would include a preliminary SI by geotechnical engineer with groundwater expert. This expert must have the experience to collect visible data and performance information of existing buildings in the immediate area. And secondly, this will enable the team to complete the office phase of the evaluation and discuss the finding with the owner and architect to prepare the detailed site development plan. That's all for chapter number 3. Hope it will help you out in your career enhancement. All the best. Thank you very much.